Hey guys, this is Mr. Grice for Algebra 2, Unit 7.1 Notes, Day 1. Today we're going to be talking about simplifying rational expressions. Our learning target today is to be able to apply the rules of simplifying rational expressions. So, quick question for you. Does 5 times 4 divided by 5 equal 4? What do you tell me? How are we supposed to do that order of operations? Well, we do the top first, and 5 times 4 is 20. And then 20 divided by 5 equals 4. So does 4 equal 4? Yep, it sure does. So what about part B? Well, remember, we have to do order of operations, so I have to do the top first. And 5 plus 4 is 9, and 9 divided by 5, you can even take out your calculators for this. Most of you should know, like, that's not gonna give me 4. 9 divided by 5, yeah, it's 1.8. Sorry, wah wah. So it does not equal 4. So, some important rules for canceling and reducing. Monomials can be reduced with any monomial, even if they're not the same. Just remember that monomials do not have addition or subtraction signs. Now, polynomials can only be canceled with polynomials that are exactly the same, okay? And then remember that polynomials have addition or subtraction sign. So let's go ahead and take a look at these. So can anything be canceled or reduced? If so, simplify the rational expression. So what we were just talking about, we have a polynomial divided by a monomial. I cannot just cross those x's out because we have addition. So I can't do anything else. This is our answer. Okay, so can anything else be canceled? No, we can't. That's as far as we go. Now for 2, I have a monomial with the polynomial, and on the bottom is a monomial. And those are the same, so I can cancel out my x's, and the only thing that I'm left with is x plus 4. So this is simplifying. Everything that is the same, I can cancel out. So there's my monomial. I have a polynomial. And on the bottom, I have a polynomial. And I can cancel out. You can put parentheses around it if you want to, but you don't have to. But since they are exactly the same, I can cancel them out. And the only thing that I'm left with is x. Okay? So if the polynomials are exactly the same, I can cancel them. But if not, I can't. Okay, and now don't get all happy like, oh, look, they're the same. Don't forget there's a square there. So the first thing that we need to do is rewrite it so it's x plus 4, and then on the bottom we have, we don't need to have the parentheses, x plus 4. And if you notice, everything is the same, okay? So I can just set up which ones are the same, and then I have 1 x plus 4 left over. All right, number 5. I have 2 monomials and then my polynomials. Now my polynomials are not exactly the same, so I can't cancel them. But I can cancel the x's and then reduce. 4 divided by 2 is 2. That 2 is on the top. I still have the x plus 2. And on the bottom is x minus 2. Okay, so number 6, we have our monomials and then a polynomial. Looking at the x's, who wins, the top or the bottom? Yeah, the top, and the top wins by 1, and then on the bottom, we have x plus 4. Now, since it's a monomial on the top and a polynomial on the bottom, I cannot cancel them out. All right, number 7, monomial, polynomial, 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 polynomial. Now, the only ones that are exactly the same are the x minus 2's. Yes, they're different because one's minus and the other's plus. So what we're left over is the x minus 4, and then x plus 4 on the bottom. If you want to keep it in parentheses, you can, but you don't have to, the one on the bottom. Oh, that's a good question. Why do we not have, or why does the top have to have the parentheses? Well, that's to make sure we keep these separate and to know that this is really x times that, okay? It's kind of like the factored form. Okay, now on the top we have a polynomial, on the bottom a monomial. I cannot just cross them out, that's illegal. So this is as far as I can go. There's nothing else I can do. All right, number 9, we just have two monomials. So I would reduce the fraction, and if you don't know how to reduce it, just go into your calculator, negative 36 divided by 20. Oh, that's funny, it's still 1.8. And then we're going to reduce it to get negative 9 over 5. Okay, so as I come back over, it's negative 9 over 5, and then the x's, the top wins, and the top wins by 2. All right, we're getting there. So we need to check. I can reduce, and then those guys are, oh wait, no. Aren't they the same? Yeah, they're the same. They're exactly the same. We can cancel them out. And then reduce 4 divided by 8. It's not 2. Good, it's 1/2. Okay, that 2 is on the bottom. The bigger number's on the bottom. Keep it there. Don't be moving it. All right. Everything's the same, but I have 1 on the top and 2 on the bottom. So when I cancel things out, I still have the 1 on the bottom. So the 7x plus 9. That's it. All right, and then number 12. Okay, I'm going to need to reduce, and the 5x minus 1 and the 5x minus 1s are exactly the same, so I can cancel those out. 8 divided by 12, I can divide it by 4 to get 2 over 3. And then the x's, the bottom wins, and the bottom wins by 3. So I'm just going to rewrite this so my 2 is in the middle. And there we go. I'm done. Okay, so just remember we got to check for the monomials with monomials, and but then polynomials can only be reduced by other polynomials if they are exactly the same. Okay, So your homework on the other side, 7.1 practice, A. Oh, mine's all jacked up so you can't really see it. Right? Or can I zoom in? Oh, that's all that came out. All right, well, that's what it is. If you have any questions, please come see Ms. Carranza or myself. We would love to help you out. Otherwise, this is Mr. Grice signing off for Algebra 2, Unit 7.1 Notes, Day 1. Thanks for watching.